Number 17. A street light is mounted at the top of a 15 feet tall pole. A man 6 feet tall walks away from the pole with a speed of 5 feet per second along a straight path. How fast is the tip of his shadow moving when he is 40 feet from the pole? So I like to draw a diagram to make this problem easier to understand. So right here is the pole, which is 15 feet tall. There's the light shining from the pole. Now the distance from the pole to the person is 40 feet tall, is 40 feet long. The distance on the ground from the pole to the person. Figure is not drawn to scale. And the person is 6 feet tall. So now the tip of his shadow is going to be somewhere away from the person and also away from the pole, so that the shadow will create a lining. The shadow will create a lining that touches the tip of the person's head and also touches the tip of the pole where the light is coming from. So as you can see, we have similar triangles. The height of this triangle is 6 feet, while the height of this triangle is 15 feet. Using the properties of similar triangles, this height, the height of the person is 6 over 15, or 2/5 the height of the pole. So the distance from the person to the tip of the shadow should be 2/5 of the distance from the pole to the tip of the shadow. So now, our related rates equation is supposed to be related to the similar triangles property. Now I know the distance based on what we know about the distances of the pole, the person, and the tip of the shadow. The distance from the pole to the person should be 1 minus 2/5, or 3/5 the distance from the pole to the shadow. And so the distance from the pole to the shadow in relation to the distance from the pole to the person is going to be 1 over 3/5, or 5/3. So our related rates equation is S, which is, let's say S would be the distance from the pole to the shadow, would equal 5/3 of, let's use a different variable. Let's say 5/3 of D, which is 40 feet, which is the distance from the pole to the person. Now to find the derivative, we take ds, derivative of the distance from the pole to the shadow with respect to time, which when using the derivative laws, it is 5/3 of the derivative of the distance from the person to the pole with respect to time. Now the distance, the d of capital D over d of t, is the how fast the person is moving with respect to the pole, which is 5 feet per second. So we just plug that into d capital D over d of t. So d capital S over d of t, which is what we're trying to find. That is how fast the shadow is moving with respect to the pole. That will be 5/3 times 5 feet per second, which is d capital D over d of t, which is 25 over 3 feet per second. That is how fast the shadow is moving away from the pole with respect to time. And voila, we were able to solve this problem using the properties of similar triangles and plugging into an easy to understand and easy to solve related rates equation.